Okay, in this video we're going to be doing Calc AB problem set 29. The problems and a playlist of all the problem sets are in the description below, and let's try to do the problems. So given that v of t is 2t plus 3 and x of 2 is equal to 5, we want to try to find x of t. So this is a reverse the power rule situation. Like, what did we take the derivative of to get 2t plus 3? All right, so x of t is going to be 2 times plus 1 times the reciprocal. So the original exponent was 1, so I added 1 to get t squared. The reciprocal of 2 is 1/2, so that's 2 1/2 t squared. The derivative of 3t is 3. I don't know how people think of that one. I always just look at them like a 3, oh, 3t, or 3, oh, 3x. Like, I just think like that's the slope. The slope of what? That's the slope of 3t. And then we put a plus c because we don't know if there was a constant there that when we took the derivative went to 0, because the derivative of every constant is 0. So that's what we have so far. I'm going to clean that up, not make you watch. T squared plus 3t plus c. Now to solve for c, we know that x of 2 is equal to 5. So we're going to say 5 is equal to 2 squared plus 3 times 2, or 6, plus c. So that's 5 is equal to 10 plus c, which means that c is equal to -5. So overall, that means that our function x of t is t squared plus 3t minus 5. Good problem, pretty straightforward. Once you've done a lot of them, it will be the most straightforward problem you can imagine. Let's look at this. Use the graphs of f and g above to answer the following. Find h prime of 7 for h of x equals f of g of x. Okay, so that's the chain rule. That like is the thing that you take the derivative of for the chain rule. So h prime of x is going to be f prime of g of x times g prime of x, and then we're going to plug in 7, sorry. So h prime of 7 is f prime of g of 7 times g prime of 7. Now what do we do? Well, now we got to find these values. So step 1, I need to know what g of 7 is, and I need to know what g prime of 7 is. So g of 7, you can see on the graph I put a little dot there. G of 7 is 1, so I'm really doing f prime of 1 times g prime of 7 is the slope of the graph of g through 7, which is down 1 over 2, so -1/2. Now I need to know what f prime of 1 is, so that's going to be the line segment passing through x equals 1 on the graph of f, and that has a slope of up 3 and over 4, so that's going to be 3/4 times -1/2, which is -3/8 for our final answer. All right, not bad. These happen a lot. Like, you run into this type of question, I would say kind of frequently. Or like you're given different representations, like maybe g of x would be a table of values and f of x is a chart, or is a graph. Who knows? All right, so for b, h prime of 2, h of x is f times g, so product rule. So here goes. H prime is first derivative of the second plus second derivative of the first. Got to get those down, right? All of the rules, can't let them slow you down, can't let them trip you up. We're just going to plug in 2, so I'm not going to make you watch that. Now we need to start collecting our values. So f of 2, you can see is like 3/2, right? And I'm not really estimating because if you go over 1, you go up. What is this? If you go over 1, you go up 3/4. So if you go over 2, you go up 2 over. If you go over 2, you go up 2 times 3/4, which is 3/2. Also, it's just halfway to 3, however you want to do it. G prime of 2 is interesting, right? G prime of 2 should be the slope of g at 2. We have a sharp turn, right? So since there's a sharp turn, G prime of 2 doesn't exist. So what I'm going to do is I'm just going to like cross that out, and I'm going to say that H prime of 2 does not exist because G prime of 2 does not exist. G has a sharp turn there. You can't salvage it after that. As soon as you hit that point, the derivative is not going to exist. So that's actually, is that nicer? I think it's kind of nicer than like having to actually calculate something. But interesting problem. All right, that happens a lot when I make these because it's kind of hard to make two graphs that interact in such a way that like when you take f of something and then look at g of that value, there's going to be a slope. I don't know. It still makes for interesting problems, but like maybe they're mostly mistakes. Who knows? All right. Given the slope of a curve at all points xy is given by 5x plus 2y squared, write the equation of the tangent line at -2, 3. All right, so the slope is always 5x plus 2y squared, so I just need, that is the derivative. It's implicit, but it's the derivative. So I need to evaluate that. at the point negative 2, 3, which means every x that I see is going to become a negative 2. Every y I see becomes a 3. So that's going to be 5 times the quantity negative 2 plus 2 the quantity 3 squared, which is negative 10 plus 18, so just 8. And then our tangent line in point slope form, y minus 3 equals 8 times the quantity x plus 2. That's all there is to it. Good problem, I think. All right, we want the second derivative as a function of x and y. That's a very common set of directions for x squared minus 2y squared equals 6. All right, step 1, we got to find dy dx because there's no like straight shot to the second derivative. So I'm going to say that we want the derivative with respect to x of both sides of this equation. Now let's actually do that. So the derivative of x squared is 2x. Then we're going to have minus 4y dy dx, because remember, we're finding the derivative of y with respect to x, which is dy dx. And then the derivative of a constant is 0. This is where if you forget, well, I mean everywhere, if you forget the derivative of a constant is 0, you're in trouble. But in these problems in particular, like you make the problem so much harder if you forget that, because you like inadvertently create like a harder quotient rule or some, I don't know. All right, we need to solve for dy dx to carry on. So dy dx is x over 2y. I think for the purpose of finding the second derivative, it's a little easier to think of this as 1/2 the quantity x over y, because then I'll just have 1/2 the quantity derivative when I find the second derivative. Let's find the second derivative. The second derivative is going to be 1/2. Now I'm going to find the derivative of x over y, which is a quotient requiring the quotient rule, implicitly. So it's the bottom derivative of the top minus top derivative of the bottom is dy dx, all over the bottom squared. Now this is not in terms of x and y. This is in terms of x, y, and dy dx. So we need to replace the dy dx. So to do that, we still just have 1/2 y minus x. dy dx is x over 2y. So I'm going to replace dy dx with x over 2y. Close it. And then, we got this stuff. Okay, so now I need to simplify this. Inside, just looking at the numerator on the inside, I'm going to get a common denominator of 2y, which gives me 2y squared minus x squared over 2y, all over y squared, which becomes 1/2 the quantity 2y squared minus x squared over 2y cubed. And then finally, you can distribute that 1/2 back in and get 2y squared minus x squared over 4y cubed. That's the problem set. All right, so I hope you found this helpful, and good luck.